We're going to start working with some lights, and this is week 8. Lights, sound. And then also, if you guys, have any things that you want me to touch on in class, like let me know ahead of time, and I'll include those. This is kind of I'm going to now gear these towards what your projects are, and I'll start trying to give you guys any secrets I can that would help you facilitate pulling off whatever you're doing. So just let me know if there's something that's having problems, then we can discuss it as a class as a whole. But definitely give me a little heads up so that I'm not completely blind about it. So let's turn off the light source and start making your own lights real quick. No fog, no lights. Sure. No sky, but a box. All right. So you've seen we have point lights. We've used those a lot in labs. And there it is. A point light is only about position. It doesn't matter how you rotate it. It's always going to have the same circular fall off. And it is just a positional thing. As I move it left to right, that's to make the light move. You see how it shines across the grid. The exact opposite of that is a directional light. I'll turn off the point light real quick by taking up its visibility down the details. So it doesn't matter where a directional light is. All that matters is a rotation. So as you see, I'm rotating around. I put some more items in here. Just maybe that made sense. Maybe you thought about that, but you hadn't actually put it to use. You haven't really thought about it yet. So that's a good way to remember them. So basic. Put a cube on here. You see that side. And then if I drag and hold down Alt, there you go. So now we can see as we rotate around, you see on either side of those things, we're moving the shadows around. Okay? Those are your standard ones. We do have a spotlight. Spot. And the spotlight has a cone, so it is kind of a directional light, but it has much more of a fall off. It only shows light within the cone. I'm going to turn off the directional light real quick. And the rendering at the bottom, and there's visibility at the bottom. All right, so spotlight has a cone, and it has a fall off. So as I get further away, it gets lighter. As I get closer, and you see it has a cone. It comes off. We should go really quickly through the details of the spotlight because we're going to use it a little bit later. It has an intensity, so I can make it brighter, of course. You see that? A lot brighter. Then it has an inner cone angle and an outer cone angle. This is kind of like a fall off. So as I bring up the inner, you see that everything that goes between the center and the inner cone will be 100% brightness. And if I bring this down, make it a lot more apparent. So starting at the edge here and going there is the fall off. And I can make the outer cone also spread a little further should I want to. And then this attenuation radius is how far off it goes. So I bring it up here, you see it shines at nothing because it's too short to actually even reach the floor. There's a lot of other things you can mess around with. The settings, I'm not going to go through all the details for you. And just to go back to the point light real quick, that also has a attenuation meaning the fall off. So with this light on, that's kind of like the name of the game today is attenuation. It has a brightness, intensity, and then it has how far it takes to fall off. Bring that in. You can see it only goes for a little bit. And then of course you guys have seen we've messed around with color. You can just set the color. You don't do it through blueprints. You can do the color just here and set an absolute color. That'll be the way it looks when it starts off the set. Well, starts off. Okay, so we have this point light, and it's set. You see these different mobilities. The different mobilities we saw when we were trying to do collisions and trying to do physics objects. That we saw that things that weren't set to movable couldn't move. Lighting is beautiful and unreal, but it has to be able to be rendered, and you have to allocate memory to rendering. And so sometimes you have to be smart about how you do lights. And a lot of things I've seen people get into that I have questions for is if I have movable lights which need the most amount of resources. Let's say I have a bunch. Should have a few more. All right, and I'm gonna go ahead and build my lighting. I wonder how long this will take on this laptop. So lighting's good. These are all being designated as movable. It means they have dynamic shadows. If I take all my point lights, make them static, they just double them up. What does do? I wonder if that's something that got fixed in 4.13. I should read the release notes. Anyway, we're going to move on real quick, and I'll come back to that in a second. So the one thing to remember, though, with static lights is that you can't have moving shadows. If I were to make this box move up and down, let's put these lights, all these lights, up, above. All right. So we have this wonderful box here. They're all set to static, and we have this shadow. We're going to bake in that shadow by building light. And I'm not going to worry about making a blueprint real quick, but as a shadow, if I were to actually move this object, that shadow stays there. So this is like when I'm talking about the resources. You have to move these to like movable things would have dynamic shadows. And if you just mouse over it, it'll tell you what it could do. See, it says totally dynamic, creates dynamic shadow. It's the slowest to render, which means it could be a resource hog. And there's just it gives you some tooltips and lets you know some of these things. Okay, so another thing that's important, and you've probably seen this error, is what's called light mass importance. This is what would give you that red arrow in the top left of your screen. Importance or light mass importance volume. So this object just says where you should be rendering your shadows. This is a very small world, so it's not as important. But this object just says only pay attention to making things beautiful right here. You can have a giant world. That was too big, but anyway. But this says only here is important. This is giant, but still, it's much better than being like an infinite landscape, which I'm really not going to build for right now. What's important? Great. All right, so let's talk a little bit about color theory. I know that some of the groups are talking about some different kind of color theories about how they can relate to emotions and attitudinal states and stuff like that. But I'm just talking about color theory as in what looks cool, what's designed well. There are a few kind of ideas of color theory, but one of the great websites is Adobe Cooler. I don't know if you guys have used it. It's been around for a little while. And it has color schemes, and this could be you can export these color schemes and load them into Photoshop and Illustrator, and it'll dynamically change your entire presentation to only using these colors. It has some ideas about color rules, like do you want them to be analogous, meaning in the same area? Do you want them to be complementary, where they're completely opposites? You can have things set up in different patterns, and then you design your own, move them around, change the wheel. And then you can export these, I think, as an ASE file, which you can import into all your Adobe products, and then it will change your design layout, just all over if you set it up correctly. They also just have the ones that are already made, and you can look up like what's the best ones, what are the most popular, which ones are the most used, and you see like now we're looking like it looks like an interior design magazine. It's like this is like what? This is like J. Crew. Right here, all the years of J. Crew. But you've also might have seen the whole joke about the blue and orange lighting for movies. Why every movie looks sort of orange and sort of blue. And there's like YouTube videos, there's a lot of things, and they get into it, and you're like, oh yeah, all the shadows are blue, and all the highlights are orange, and then they just like show you that every movie is blue and every movie is orange, and it's because it works. But definitely pay attention to it. It's a thing. So whenever you're like, my shadows don't really look that movie, then make your shadows blue, and you're like, oh, okay. Unless we're at the Matrix, which of course is like green, right? And that gets into like color, the color theory. Ooh, newsletter. All right. Now, so I'm just gonna get rid of my lights really quick. And I'm gonna get rid of these things, which are called cubes, not just things. And go to sphere. And I'm gonna bring in let's see. Get rid of these guys. So I'm starting just from a sphere. And come down closer to it and hang out with it. And if I build that lighting, it's going to be boom. All right, point light, point light. Let's apply our theory. We're going to make the background be a little cool blue. And I'm going to make the foreground a cool orange. When I say cool, I mean awesome, but not actually cool. And then give it a little foreground. Let's raise them all up a little bit. Inside. Come out. Come out. So this is what's called three-point lighting, give or take, inside of the world. And it just, all of a sudden you see how, as you move around this object, it kind of changes tone, gives some contrast. If you threw in a character, you see how this moves a little bit forward. Orange overtones, nice and smooth. Let's take all these guys and see. Shadows, take off shadows. There we go. Anyway, so this is just this is a really cool, simple idea that well, I guess we just throw it into the world and check it out. 1 second. So I'm gonna put this into a blueprint real quick, just so we can see this dynamically. We're going to actually, I'll do this later on. I'm gonna get into the sound real quick. Make sure we have enough time for everything. I'll do this in a second. Save this Untitled, it's not for me. All right, so let's find some sound source stuff. All right. So there's sound all over the internet. Just like we found the free 3D models. If you want to find a crappy source of free sounds, it's freesounds.org. There's some great ones too. But there are a lot of free sound.org. Let's see. And so it has a pretty cool visualization of the sound. So here's one sound, but we'll just search for something like a helicopter. So you see there's different kind of waveforms, and they're color coded, and those actually represent pitch. The height is amplitude, and the color is pitch. I think that's pretty cool. So you can just like preview them here. I might have to choose the output being the screen. Let's see. No, here's something. Just quiet. So that's blue. Blue is a lower tone. Let's try, and that's orange. Much higher tone. So it's like a little rooms, little quadcopter. Look at this one. This looks like a sweater. High and low. And it has ratings and stuff like that. This is great for finding like a room tone, finding an ambient tone for your world. You want to have an environment, and you want to have like a babbling brook and the sounds of doves crying or whatever, and you you need to find a quick one. Let's see if actually what is the sound of doves crying. All right. All right. This is what it sounds like when doves cry. All right. What's the sound of one hand clapping? Okay. Tree falls in the woods. No results. Okay. I'm on the internet. So I'm gonna be boring, and I'm gonna get some white noise. All right, so this is gonna be huge. This is gonna be so loud. You see the amplitude is already maxed out. I'm gonna grab this one, but I'm not gonna listen to it. I'm gonna put it into an audio editing program, just so we know a little bit about audio editing, so we can massage our sound files before we put them into Unreal. There are just like movies that had to be an MP4 or MOV. Sounds have to be a waveform and have to be 16-bit. And I'm going to show you that in another piece of Adobe software, Adobe Audition. So you have to sign up for this website. I'm going to grab this huge noise that's 50 seconds long. It's been downloaded 11,000 times. People have comments about it. I'm using this one for technical difficulties. Wow, it's like a social platform for sound files. This is great. Love it. Awesome. I use this as the trim for my orbital simulator. And this is MP3. And MP3, maybe on 413 it works now, but previously it did not work. So I'm going to show in the Finder. There it is. Great. Fantastic. And we're going to open up Adobe Audition. We're back. We saw that we could do modulation. That was great. We were downloading another sound, I think is where we were. And we just wanted to see some sounds, some steps. So let me go back to my downloads folder real quick. We have these footsteps and puddles, and then go back to Audition, drag that in. And what I'm going to do is I'm going to save out like 4 steps. So great, those are the 4. So we will copy to new, boink, go back here, we will copy to new, great, go here, and we will, you guessed it, copy to new, and one last time for the folks at home, we will copy to new.
So now I have 4 files that are all different steps. We're going to save each one as something new, foot 1. And my settings from previously are saved, so I don't have to change it. This one is stereo instead of mono. You see it has 2 tracks there. That's fine for what we're doing for right now. Foot 1, foot 2, foot 3, and foot 4. Hide audition again. Take these guys, toss them on in. And now what I'm going to do is I'm just going to create a cue from scratch. And we're just going to call this one for audio sounds. So now instead of right clicking, I'm just going to make one by itself. And this one's going to be called feats. And I'm going to take this and take all 4 of these guys and throw them in. Just like we did with 4, oops, no way. Just like we did with 4 textures into one material, we do 4 sounds into one cue. And then this is all just to show you that this is how you do footsteps. Is you get just a bunch, and then so you don't feel that you don't see that that pattern, you take in something like a random, and the random can have multiple inputs. Let's cross the streams, join. And then I'm going to use a modulator, and I'm going to throw that in there. And then we'll modulate a bunch, like 8, 1.2, and then we'll see infinitely different footsteps. So that sounds pretty interesting. That's what it's done. What's kind of fun is you can actually put like trigger boxes on your parent them onto the feet of your performer, the character, and actually they can actually generate footsteps as you walk. And so you just put 2 of these cues on each of the feet and trigger boxes, and boom, 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 they're generating their own footsteps. That's like a little fun trick. So I want to do something a little different with these lights, though. I want to change. So we're going back to lights. I want to change the intensity of all these, and we've seen we can change the intensity through blueprints and stuff. But I'm going to do it through a material. I want them all to flicker together. I want them all to have a similar property. I'm going to do a new level real quick, though. And this one, I'll do one. Yeah, we'll do it this way. Sure. So we're in this empty world. Bring in a cube. Make the cube big. Then I'm going to bring in. I'm going to make a blueprint before I import it in. Start from scratch. Blueprint. Actor. This can be called BP Hella Light. And I'm going to start off with, I have this default scene root. I'm going to use that as the root. I'm going to parent that. I'm going to parent a bunch of things to it and use this as kind of the locus of motion. I'm going to add in 4 spotlights. Spotlight. Spot. There we go. All right, so the spotlight. I'm going to rotate it. .90 degrees. There we go. And I'm just going to offset it 400. the side, duplicate it with Control W, do that one for negative 400, and then 2 more. This one will be on the other axis, 400, 0, and then negative 400, 0, oops, 0. And we now have 4 spotlights that are pointing down. I want them all to be the same. Let's bring up the inner cone angle a little bit to like 25 and make them a little brighter. And I'm going to throw this into the world so we can see what we're doing. There we go. There are the spotlights. That's cool. A little centered. Cool, but I want to change all of them at one time, and they're all in the same blueprint. Well, you can put blueprints inside blueprints, but I just want to do something called a material function really quick. So I'm going to actually make material that goes into all these lights. I'm going to grab the bodies and motion logo, which is totally not ours. It's just something I found on the internet. I mean, extra points. You come up with the body's motion logo. I can't even move the browser right now. All right. I mean, the resolution is like it was made with a potato. But that's fine. We're gonna use that. That's gonna be our aesthetic, right? Bodies of motion, making graphics with potatoes for years. All right. So just like I would make any other material, I'm going to create a material with this one, and then let's open it up. And what I said before was we're going to make this a light mass. This is actually done here where it says material domain. We say it's a light function, not light mass. Sorry, just light function. Now it's emissive. But I want it to be the opposite. Let's take a look at it here. Boop, there's a logo. I want to actually just shine the logo itself in light. So a little math here. I'm going to do a 1 minus. This is the inverse. There we go. I can also just preview it here, and we see that that's the inverse. Yeah. And well, I think that's really cool. But also, so let's see how we can put this on the slide. We're going to make the floor a little bigger. And oops, didn't need to do that for the bottom. Let's do this like this. There we go. And then if we go to our hello light, we can peek into that blueprint right here. And on all of these guys, we're going to scroll all the way down, and it says light function material. Booyah. There you go. So now we have super cool logo, and we kind of want to go disco on this a little bit. So I'm going to go back to this blueprint, and a little bang for your buck, this thing called a rotating movement. And that's all it is. I said rotating movement. That's all I care about. Let's see what happens. All right. That's cool. Maybe a little dizzy, but you know, it's going to get worse before it gets better. Actually, yeah, let's make it worse. So, take our spotlight, and on every tick, we're just going to go ahead and add a local rotation. Let's take up create CC. Local rotation. cool. And I'm going to do it so they rotate around the center. And let's see if this does something. Kind of doing it, kind of not. I think the center was wrong. Maybe I just have to, no. Well, anyway, that was crazy. We don't get too sick. That was working a little bit. Add local rotation. So I just had rotation. Let's add the active location and see if that works. No, we'll just move on. This is just for fun. Quick thing, I can hold down, I think Control, just, oops, no, Command on a map. I just grabbed all of them at once. Yoink. Oh no, I want to do it for the actor, not this is a component rotation. So we're not going to worry about it. That's fun. Anyway, moving on. So the next thing I want to do is I want to go back to this wonderful world of white noise. And instead of using a modulator, I'm going to use what's called Doppler. Has anyone had experience with Doppler before? So Doppler is caused. The Doppler effect is caused by the compression and rarefaction of sound. Meaning, as the sound goes by you, the sound waves are compressed because the object is moving at a certain speed, which actually compresses the waveform, making the waveform shorter, making it a higher frequency, and therefore creating a wake that also has a lower frequency behind it. Ambulance goes, that is Doppler effect. Doppler effect is the physics of sound. It's built into a physics engine such as Unreal. So before we get too far, though, I just want to prove that just like the lights have a fall off and everything, let me get this real quick. Sound also has a fall off. If I come down to the details here, we changed the attenuation of the lights, but now we can do it for a sound. You see that everything inside the circle will be louder, and then it's all the way out here, we can't hear it any longer. So now that we have the attenuation, there's definitely settings. That could be a linear setting. We can say how big we want the a little bit so see. I'm going to say that I want the inner radius is 400 is fine. We're going to move the outer radius to like 600, so it's much smaller. And 6,000 is not smaller, 600 is. There we go. So now I can kind of fly around when I hit play. And let's see. Can't hear anything. Closer, closer. All right, we entered in. Oh, I don't have it on looping, so it ended. Loop. There you go. So now it's looping. I hit play again. Super loud and quieter. Light goes on, light goes off. And so now I'm going to go back to this blueprint we have going here real quick. I have my cue. It has Doppler effect in here. Doppler intensity. Let's just boost it so we can hear it. Save it. Bop it. So I'm just going to take this audio and I'm going to put it on each of these spotlights that are rotating around. Where'd that come from? Go back. Go back. Well, fine, I don't need you. So audio's underneath one, audio's underneath the other one, audio's underneath the other one, and I can always import it from scratch over here, and then they're all parented to one of the spotlights. If I select each one, how can I do that? Let's do one at a time then. I'm going to get rid of any offsets so that they are exactly where lights are. That was beautiful. They should have gotten a chorus of people singing or something like that next time. I'm just going to make the attenuation much smaller on the cues. So go back into the blueprint. And we got to override the attenuation. That's what I didn't do. That was not going to get us anywhere quick. So 200 to 400. So now each one of the sounds has an attenuation that's linear. And see if I could just copy and paste this a bunch of times. Sorry for the tedium. All for one grand payoff. Audio is fine. Okay, audio, 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 and all of them have attenuations. Alright, let's get back in there. Save all. Sure. Let's try it. Well, I think that's the same thing. We should have done it like a sine wave tone, so I could actually heard that. Anyway, it works in the demo. If you want to go in the other room, I did this today once. So I just want to do one more thing with these lights. We see that we can add these beautiful little materials to it. So let's have a little bit more fun with the light material. And I'm just going to kind of grab time and get rid of any kind of floating points from it. And see if we can make this, see what this looks like. Wrong way. And let's multiply it. There we go. Just in time for Halloween. There we go. So now we're using time to make this light. So basically, this can also be on a timeline. This would be on OSC. We're using this one material to like kind of override all the settings. Each of these lights can be their own color, but they're not blueprints. I can go back into them and make one the gorgeous blue. There you go. And with our lovely annoying. So essentially that's all I want to show you tonight. We're going to get into more interactivity. Now you know colors and sound, lights, and I'll post some great other resources on Slack for week 8 for getting free noises, for getting like cool hoops, for getting atmospheric stuff. And obviously free sound is a little bit Wild West, more organized, and I think we even have some libraries at both schools of like sound effects and all kinds of stuff. If you want to start importing them. The main thing to remember is that if you put a sound into a world, where's my world? There we go. It auto activates, which is that setting down here. Auto activate. And if you want to do it in blueprints, or if you want to do it on events, if you want to do it on triggers, you have to activate it inside of a blueprint. So we won't be able to hear it because of the craziness of that world. But then I would just take the sound, and then I would activate it. Like that. Does anyone have any questions about any of that kind of stuff or ideas or anything like that? Okay. It's pretty far out there. All right, so I'll go ahead and stop the recording here, and then we're going to